Okay, everyone, let's begin then. So we were doing trigonometry, and in the last couple of sessions, we have done a number of concepts. We started with this, that in a right angle triangle, we can use Pythagoras to find any missing sides. And then we have these three trigonometric ratios, sine, cos, tan, which we can use to find any missing angles or sides. And then we talked about the case when the triangle is not a right angle. In this case, you can use sine rule and cosine rule. We understood when to use which one of those rules. We looked at a few examples of that. Then in the last session, we talked about some properties that you need to know for triangles, and for that, and before that, some angle properties like angle on a straight line is 180 degrees, vertically opposite angles are equal, then corresponding angles, alternate angles, all of these different things we discussed in the last session. We will spend a bit more time on this on angle properties later on, but since there were some things that we need to use in trigonometry, I gave you a quick overview of that. But then primarily in the last session, we talked about the different types of triangles that we can have. We started with equilateral triangles in which all the sides and all angles are equal, all angles are 60 degrees, and all sides are going to be equal. An isosceles triangle in which two sides are equal and the base angles, what are base angles? The angles that are opposite to the equal sides, we call them base angles. They're also equal. We talked about that and how to find any missing angles in that. And then if you were to draw a line to the base side from the third vertex such that it cuts the base at the midpoint, the angle that this line makes is always going to be 90 degrees. And also the other way around, if you were to make a 90 degrees line from that third point to the base of this triangle, the base will always be divided into two equal parts, right? That's what we covered in the last session. And the same thing we did for equilateral triangles as well. We talked about area of triangle, half into base into height. That's one formula that we can use for area of triangle. In this case, base has to be one of the sides of the triangle. Okay, base has to be one of the three sides of the triangle. And then height is going to be the perpendicular coming from the third vertex to the base. Okay, height is always perpendicular to the base. Perpendicular from the third vertex to the base. Okay, now sometimes it can be one of the sides of the triangle when it's a right angle triangle. At other times, when it's not a right angle triangle, the height is not going to be one of the sides. Base will be one of the sides, and then height will be the perpendicular, like this, right? We looked at the different cases that you can have in this case. Sometimes the height can be outside the triangle as well. And then finally, we covered this formula, half into AB sine C. And that's what we use when we have one angle known and two sides known, such that the angle is the included angle, the angle between those two sides. So if we have two sides of a triangle and the angle between them, we can use this formula to find the area of the triangle as well, half AB sine C. We looked at a couple of examples in this. And that's pretty much what we did in the last session. Now, today, we want to cover a couple of more concepts. First of all, the concept of bearing, right? The idea of bearing. And then we want to discuss 3D trigonometry, in which we will discuss the angle of elevation, angle of depression, how they are calculated, and also how to deal with 3D trigonometry problems in general. That's what we want to do today as well, inshallah. Okay, so first of all, let's start with bearing and understand what this is about. Okay, now, a lot of times, in fact, the more common convention is that we measure angle from horizontal lines generally, right? So if you have a point, for example, if you have a point here like this, when you measure angle, the most common convention that we have is that we measure angle Okay, I'm sorry. There was some problem with my internet connection. I got disconnected, I think. Can you hear me again? Okay, you can see the screen again as well, right? Okay, good. All right. So generally, the convention is that we measure angle from horizontal lines in anti-clockwise direction. That's what you would mostly be doing whenever you measure angle. But there's another convention that is sometimes used in some industries for navigation purposes, basically, that if you're going straight, then if you have to go right, left by a certain angle. So imagine somebody going uh, straight like this, right? And then you want them to take a turn, right? So often they do it in for navigation in flights or uh, anywhere where you need navigation. So if you're going straight like this, for instance, and then they want you to turn by a certain degree. So let's say they want you to turn by 5 degrees. Then that 5 degree, where is that measured from? From this vertical line that you're going straight like this. And then if you want to turn right by a certain degrees, let's say 10 degrees, then they would say, okay, turn 10 degrees from here. Okay. And you would change your direction by 10 degrees from this vertical line, right? And similarly, you can go left as well. Now, this idea that you measure angle from a vertical line, this is known as bearing. Okay, now I'm just adjusting my pen size a bit. Okay. So the idea of bearing is that we measure angle from a vertical line instead of a horizontal line. Now, how do we understand that? Let's say we have a point here, that point is A, and we have another point B. First of all, we will always be measuring angle bearing is always measured, number one, from north. Now, I'll tell you what that means in a moment. And number two, in clockwise direction. That's the convention that we have for bearing. So you have 4 directions, which I'm sure you guys would be familiar with. So you have, if I were to draw 4 directions here like this, generally what we do is we represent vertically upwards as north, and then this becomes south. Right is generally denoted by E, and then on the left side you have west. Okay, so when you represent directions on a 2D diagram like this, you represent it like this, that vertically upwards is considered north, right is east, this is south, this is west. Okay, now when you're measuring angle for bearing, you always do it from north. Okay, so basically from this line here. And you do that in the clockwise direction. So you go like this from the north, in the clockwise direction. Okay, so that's the direction in which you will be measuring angles. Now let's take an example of this. Let's say you have 2 points like this, points A and B, and they can be connected like this. And what you know is that this angle here is 30 degrees. Okay, that's what we know. And let's say that's all that we know. Now, if I were to ask you, what's the bearing of B from A? Bearing of B from A. Now, what does that mean? From A means that you are going to be measuring angle from the point A. Okay. A is the point of reference. So the point that comes after from, that is your point of reference. That is where you will be measuring your angle from. So where do you measure angle from? From the point A. Now, whatever comes after from, what you do is you make north at this point. So what you do is you draw a vertical line there and they're pointing upwards, and you say this is your north direction. Okay. This is where you will be measuring angle in this example, because you have to measure angle from A. And then we have to go in the clockwise direction, right? Towards the right side from this north. What's the bearing of B? Okay, so of B, we have to measure where this point is. What's the angle of this point from this north at the point A? Now, how can we do that? If we go in the clockwise direction like this is the angle that we get for the point B. B is in this direction, right? Now, what's this angle? Can we find this out? This is a 90 degrees, right? With the horizontal line, north makes a 90 degrees. And then you have this additional 30 degrees. What's the total angle that you get here? That's 90 degrees plus 30 degrees. And that turns out to be 120. And that's your bearing in this case. Okay. Now, if you were to switch this, for example, if I were to say, what's the bearing of A from B? Bearing of A from B. Now, again, the point that comes after from, that is where you're going to make north. Okay. This is the point where you're going to be measuring angle from. So you make a north at the point B for the second example. That would look something like this. You make a north at B at this point, and this time this is north. And now if you have to find this bearing of A from B. So now you have to measure angle from this north. In which direction? In clockwise direction. Let's see what we get when we do that in the clockwise direction. Before that, can you actually mark this point, mark this angle? If this is 30 degrees, if I were to make a horizontal line here like this, what is this angle going to be? This is also going to be 30 degrees, right? Alternate angles. These are parallel sides. These two sides are parallel. If we have a line passing like this angle 30 is going to be equal to this angle 30. These are alternate angles. This angle is going to be 30 degrees. And now what we can do is, we can go like this from this north. We can say, okay, let's go in the clockwise direction. This point is B. Let's go clockwise from here. This is the angle that we're looking for. Now, what's this angle? 90, 180, 270, right? Plus this 30. What do we get from that? So we have this 90 here, another 90 here, another 90 here. So that's 270, right? If you want, you can write it like this first, 90 plus 90 plus 90, right? So we have 390s, and then we have another 30. What does that give you? That's 270 plus 30, essentially. You can do it directly as well. And that gives you 300 degrees. That's the bearing of A from B. That's the bearing of A from B. All right. Now, let's take another example. So in this case, it was just a line. Now, let's take a triangle. Let's say we have a triangle that looks something like this. And consider all the different possibilities that we can have in this triangle as far as bearing is concerned. So let's say I have this triangle. Let's call this triangle ABC. This is A, this is B, and this is C. And what we know is that BC is a horizontal line, okay? And we know the angles in this triangle. Let's suppose this angle here is 70 degrees, and then this maybe is 60 degrees. That's 130, and then this angle is going to be 50 degrees. Okay, so we have the angles like this. Okay, it's a triangle. And now what we want to do is we want to find the bearing of B and C from the point A first of all. Let's start with that. Now, let me write that down here. Bearing of C, or let's start with, okay, bearing of C from A. Let's say we want to figure this out. And then we want to figure out what the bearing of B from A is as well. Now, how do we start? Where do we make the north? The point that comes after from, what's that? That's the point A, right? So the north is going to be made at the point A in this case, okay? Because that's what's coming after from. This is the point of reference. You make a north at this point. So you make a vertical line pointing upwards at this point. This is your north. Now, angle is going to be measured clockwise from here. In the first case, we are finding C. What is that going to be? That's this angle here, right? That's what we're looking for. What's this angle? That is going to give us the bearing of C from A. Now, how do you find this angle? Let's think about it. This angle is 50 degrees in the triangle. And I told you that this is a horizontal line. This base is horizontal. So if I were to make a line here like this, can I write down this angle? 50 and this angle, and they are alternate angles, right? This angle is going to be 50, therefore. So what's the bearing of C from A? What is that bearing going to be? Let's write that down here. That bearing is going to be 90. That's this angle, plus this 50. And that turns out to be 140 degrees. Okay. All right. Now, bearing of B from A. How do you find that now? B from A. Again, we already know what this angle is now. This is 140. We already found that, right? Add to 140 another 70, because the bearing of B from A would be this here. Okay. So what's that going to be? 140. We already found that this angle here is 140. Go 70 more, and that will give you the bearing of B from A. And that turns out to be 210. That's the bearing of B from A. Okay. Now, similarly, we could do it from another point as well. What if they were asking for the bearing of A from B and the bearing of C from B? Okay, now let's be quick about these. Now, A from B, what does that mean? We make our north at the point B, right? That's where we're going to be making our north at. Point B, that's your north. What's the bearing of the point A, first of all? Go in the clockwise direction, find this angle. If this is 60, we know that this total angle is 90. So this remaining angle is going to be 30 degrees, right? So the bearing turns out to be 90 minus 30, 90 minus 60. That is 30 degrees. Now we have another convention for bearing, and that is we generally write bearing as 3 digits. Okay, so instead of writing 30, we should write it as 030. So bearing is generally written as 3 digits. Okay, before decimals. If there are any decimals, before decimals, we write 3 digits generally. So 030, that's the bearing. Okay. Although sometimes they don't deduct marks for this, but they expect you to write it this way. So write 3 digits like this. Okay, and then bearing of C from B, that's just a right angle, right? This angle here, this is right angle. We can just write 90 degrees directly. There's no calculation needed. Add a 0 to that in the beginning because that's bearing and that's written to 3 digits like this. Okay, now very quickly, let's do the last one as well. If we were to find bearing from the point C, let's see what that turns out to be. Now let's say you want to find bearing of A from C and B from C. Now, what does that mean? In this case, the north is going to be made at the point C. Okay, so north is made at the point C. You measure angle from this point, from this line now, in which direction? In clockwise direction. Okay, so first of all, we can find B first. That's easier. 90 plus 90 plus 90, that's 270, right? We can write that directly as well. B from C is 270 degrees. And what about A? For A, we can just add another 50 to it. 270 plus 50, that gives us 320. That's the bearing of A from C, and we also found the bearing of B from C. So the idea is when you have to find bearing, number one, you always measure angle from the vertical line from the north made at a point. The point has to be the one that comes after from. So if it says from A, the north is going to be made at A. If it says from B, the north is going to be made at the point B, and so on. And from that north, what you do is you measure angle in the clockwise direction. Okay, that's the simple idea of bearing. You can do it like this. That's one thing that we wanted to do. Let's have a look at a couple of questions very quickly on this before we talk about angle of elevation, angle of depression. Let's have a look at one example on this. It's mostly just 1 mark question that I'm finding here for bearing. Okay, let's do this. S and P are two positions at C, and L is a lighthouse. S is due west of L. So these directions are important, right? This is east, this is west, this is north, this is south. Okay. Now they're saying S is due west of L. So you can see that S is to the left of L. P is due south of L. So P is right below L like this. They've shown you this in the diagram as well. You have the lengths given SL and SLP. First of all, they want you to find the length LP. Okay, now how do you find the length LP? It's a right angle triangle, right? We know that because this is the horizontal line, this is the vertical line, so the angle has to be 90 degrees. So we can use Pythagoras. That will be the quickest way of figuring this out. So that means LP squared plus 1200 squared should equal 1300 squared. Okay, so what does that give us? LP squared equals 1300 squared minus 1200 squared. And then you can take square root of that. LP equals square root of whatever that number is, 1300 squared minus 1200 squared. And then you take square root of that. It turns out to be 500. So LP is equal to 500. Okay, that's the first part. Now, let's look at the second part. It says, calculate the bearing of S from P. What does that mean? S from P. What's the reference point? North is going to be made at the point P. The point that comes after from, that is where you will be drawing north. Okay, so the point is P. This is the point that we're talking about. We will make north here at this point, point P. We have to find the bearing of S from P. So what we're looking for is this angle. Okay, this is the angle that we're looking for. Now, how do you find this angle? Angle in a full circle is 360 degrees. If we can somehow find the angle inside the triangle, this green angle, we can subtract that from 360 to get this bearing. Okay. So what we can start with is we can say, let's find this angle inside the triangle. Let's call this angle theta. Now it's a right angle triangle. In right angle triangle, when we talk about angles, what we should do is we should use trigonometric ratios directly, sine, cos, or tan, right? They will be the quickest to find the solution in this case. Part two, we have a right angle triangle. We're looking at this angle theta. We have all three sides of the triangle now, so we can use sine, cos, tan, any of them. If we were to use the sides that are given in the question itself, which sides are these? With respect to theta, 1200 is opposite, that means perpendicular, and 1300 is hypotenuse. What's the ratio between perpendicular and hypotenuse? It's sine. So we have sine theta equal to perpendicular, which is 1200, over the hypotenuse, which is 1300. We can find the value of theta from this. Let's see what that turns out to be. Sine inverse of 1200 divided by 1300. Okay, and that's giving me 67.38. That means this angle inside here, that is 67.38. What we can do now is, so we have to just show one more step here in case anyone gets confused. So I'm doing sine inverse of 1200 over 1300, or essentially just 12 over 13, right? This is the value of theta that I get from that. Now, once I have this value of theta, what's the bearing? Bearing of S from P. What is that going to be? The complete angle in a full circle is 360. So you say it's 360 degrees minus that angle theta, which is 67.38. You can see what that gives you. 360 minus this result, that's 292.6 degrees. That's the bearing that we were looking for. That's 292.6 degrees. All right. That's how we can find bearing. Now let's look at the third part as well, since we're doing it anyway. We will cover this as well. Uh, the distance, speed formulas, but it's really straightforward in this case. That's what it looks like. So they're saying a boat sailed from S to P. So a boat is going from S to the point P. How much distance is it covering? It's covering 1300 meters. Okay, that's the distance that it's covering. This is 1300 meters. Now, it left S at 1556 and reached P at 1604. How much time is that? So we have 4 minutes left in this hour and then 4 more. That's 8 minutes in total. That's 8 minutes in total. What we want to do is we want to find the speed in kilometers per hour. Speed in kilometers per hour. Okay, how do you do that? How is speed calculated? Speed is distance over time. Okay, that's how we find speed. It has to be in kilometers per hour, but the units that we have right now are 1300 meters and 8 minutes. How many meters do we have in 1 kilometer? 1000 meter. So this is going to be 1300 divided by 1000 kilometer, which gives you 1.3 kilometer. So the distance is 1.3 kilometer. What about this? It has to be in hours, right? This is minutes. How many hours do you have in a minute? How many minutes do you have in an hour? You have 60 minutes. So if you had to convert this to hours, you would say this is 8 over 60 hours, which if you were to put on a calculator, this gives you 2 over 15. Let's just keep it like this, 2 over 15 hours. So we can put that here, 1.3 divided by 2 over 15. Now we can write it separately like this, 13 divided by 2 over 15, which becomes 13 multiplied by 15 over 2. And you can see what that gives you, 13 times 15 divided by 2. That's 195 over 2, or 97.5 kilometers per hour. That's the speed that we're getting for this. It looks very fast. There is probably some error that we have done. Let me just check that. Okay, so I wrote that as 1.3. Okay, so this number looks very large for the speed of a boat. The problem was that I wrote 13 there by mistake instead of 1.3. So you have to do a sanity check on your answers as well. We're talking about a boat. 97 kilometers per hour looks rather too quick for a boat. So this was actually 1.3, which I wrote as 13 by mistake. So this should be actually 9.75 then. I'll just do this calculation again just to confirm. 1.3 times 15 divided by 2, that's 9.75 and not 97.5. 9.75 kilometers per hour. That's the result that we're getting from this. This is what we were looking for. Okay. All right. Now, let's go back here and discuss the next thing that we want to do now. Angle of elevation and angle of depression. Now, 3D trigonometry problems are what are sometimes a bit more difficult. And in most of these problems, you get asked about angle of elevation or angle of depression. Now, what does this mean? Angle of elevation or angle of depression? Let's think about it. Let's say you have a building like this. Now, my drawing is not very good, so what I'll do is I'll just make a rectangle here like this. Let's say we have this building. And you have a person standing here like this. Okay, you have this person standing. And this person is looking at another person on the ground. Okay. That person is looking at a person at the ground. And this person at the ground is looking at that person. Okay. Let's say we have a line that looks like this. Now, the person at the bottom, his eye level is basically this horizontal line, right? So if he or she were to look straight, they would be looking in this direction horizontally. So in order to look at that person standing on top of the building, how much above their normal eye level do they have to look? This angle that we have here, let's call this theta. This is known as the angle of elevation. This is the angle of elevation. It's the angle at which you have to look above from your normal eye level. Okay. So your standard eye level would be this horizontal line. Now, how much do you have to look above in order to look at this person on top of the building? That's this angle theta. This angle theta is known as the angle of elevation of this person from this ground. And then if this person on top, that person was to look at this person at the bottom, what's his or her normal eye level? That would be, again, horizontal like this. Now, if he had to look at this person here, he would have to lower his normal eye level. By what angle would he have to lower his eye level? It'll be by this angle, right? This angle here is known as angle of depression. And if you notice, these are alternate angles. This theta and this theta, they are alternate angles. The value of angle of elevation and angle of depression, it's going to be the same, but it's just a different context. If there's a person standing at the bottom and looking up, the angle that we will be talking about will be angle of elevation. And if a person is here on top and is looking down, this angle would be called angle of depression. And as you can see, these two angles are normally going to be the same. If the surface is horizontal, the angles are going to be both the same. Now, you see, the angle is always measured from the horizontal axis in this case. So from this line and from this line, that's where you're measuring angle from. A very common error here is to find, for example, for angle of depression, this angle here, that's not what we want. And similarly for angle of elevation, we're not looking for this angle. Both of these angles are supposed to be with the horizontal line. That's important to remember. Both angle of elevation, both angle of elevation and angle of depression are normally measured from a horizontal line. Okay, so when we look at 3D trigonometry problems where you have angles in 3 dimensions, when you have triangles in 3 dimensions, this is what angle of elevation and angle of depression are going to mean. Okay. Now, how do you calculate them? Generally, it's going to be a right angle triangle because we're talking about uh, something vertical like this, and then the floor, the surface will be horizontal. So between a surface and a vertical line, the angle is going to be 90 degrees. So in order to find these angles, you just will have to use trigonometric ratios, sine, cos, tan. You would have two sides given, for instance, and you would be able to find the remaining side. For instance, in this case, if you knew that maybe this side was 26, maybe this side was 10, you can find this angle by just using tan, right? You can use tan to find this angle. That will be the angle of elevation. All right. We will look at some examples in a moment. On 3D trigonometry as well. But when we look at those problems, there's another thing that you need to remember, and that is in some cases, you would have some horizontal surface. So let's say you have a horizontal surface that looks like this. So we have this horizontal surface. And on this horizontal surface, we might have something vertical. So they might say there is this point at which there is some vertical thing. So it might be a tower, it might be some other thing that's vertical like this. Or maybe I could draw it slightly differently. If I were to draw a plane here like this. Yeah, okay. So let's say we have this horizontal plane. So this is a horizontal surface. We have this horizontal surface. Think of it as a plane. So a flat surface. On this flat surface, let's say we have a point at which you have something vertical standing, right? So think of your notebook, and if you were to put your pen on that notebook in the vertical direction, it would look something like this. Right. Now, if you have other points in that plane, in the on this horizontal surface, so let's say this point here was X, and there was another point Y here, and there was another point Z here, and there's another point A here, and this point on top, let's say this point here is M. Now, if you were to join the point X with any of these lines on the surface, for example, if I were to make this line XA, and then if I make this triangle like this, the triangle AXM. Now think about it. AX is horizontal, MX is vertical, right? AX, so everything on this surface is horizontal. This yellow surface is a horizontal surface. So it's a flat surface. And this line is vertical, right? Now, if I were to make a triangle that looks like this, in this triangle, the angle here is going to be 90 degrees. So you can say the angle AXM equals 90 degrees. Okay. And not just this angle. If I were to join the point X with another point here, for example, Y, and make a triangle that looks like this. This is also going to be a right angle triangle. This angle here is also going to be 90 degrees because again, MX is vertical, XY is horizontal. So this angle here, this is also 90 degrees. MXY, this is also a 90 degrees angle. So if I were to make this triangle, this is also a right angle triangle. The earlier one was also a right angle triangle, right? We're talking about 3 dimensions here. The yellow surface is horizontal, and when we make a line with the vertical, the angle here is going to be 90 degrees. And then if we had another point Z here, and if I were to join X with Z like this triangle here, MXZ, at the point X, the angle is again going to be 90 degrees. MXZ, this angle is also 90 degrees. This is also a right angle triangle. So whenever you have a right angle triangle, whenever you have a triangle in a 3D space where one line is vertical and another is horizontal, the angle between that vertical line and the horizontal line is always going to be 90 degrees. So you would get right angle triangles like this in 3 dimensions. Okay, that's something that you need to keep in mind. Now, having discussed this, let's have a look at a couple of examples. So in 3D trigonometry, these are two additional things that you need to understand now. The concept, the idea of angle of depression, angle of elevation, and the fact that whenever you have a horizontal surface, any line that you have in that horizontal surface, it's going to make a 90 degrees with a vertical line. Okay, so you can make right angle triangles like this to find any unknown angles. Let's take an example. Let's take some examples of this now on 3D trigonometry. Let me see if I can find a couple on this. Okay, so maybe I'm looking at the wrong worksheet. This is the one. Okay, let's have a look at this now. This is question number 13 from the bearing worksheet. A boat leaves A and travels 12 kilometers to B and travels an average speed of 15 kilometers per hour. At what time does the boat arrive? I'm going to skip the first part, that's speed time. Let's focus on the next one because we're doing trigonometry right now. Bearing of B from A is 56 degrees. B is 2 kilometers due west of C. Okay. What we have to do is we have to calculate AC. All right. So we have this information given. We have this angle, which is 56 degrees. And we are given that this side is 2 and that this side is 12. This is a horizontal line. We need to find the length of AC somehow. This length is what we are looking for. Now, in this triangle, we have two sides. What else do we have there? AB is 12. Okay, so we have no additional information there. This is what we are given. These angles are given, and these this one angle is given, and we have that side given. Okay, now how do we think about this? In this triangle, we have two sides, but two sides are not enough to find any unknowns here. How can we use this angle to find any angles inside this triangle? Let's think about this. This is the vertical line that we have at point A. If I were to draw a vertical line at the point B like this north and this north, they are parallel lines to each other. If this angle is 56, what does that mean for this angle here? This is also going to be 56. So we can say the angle that you have with this vertical line, that is 56 degrees. Okay, this angle is 56 degrees. Make sense? Once that angle is 56, we know this is 90 because I drew a vertical line here, and we know this is horizontal because it says B is 2 kilometers due west of C. So from C, this is the west direction. That means it's horizontal. So this angle here is 90 degrees. So 90 plus 56, we have this complete angle. This complete angle at B turns out to be 90 plus 56, which is 146. That's the angle at this point here. All right. And what we have to do is we have to find the side AC. That's what we're looking for. Okay. How can we do that now? Do we have a side angle pair? Let's think about that. We know this 12 side. The angle opposite to that is this. Do we know that? No, we don't have that. This is 2. The angle opposite to that is this. Do we know that? No, we don't know that as well. So we don't have a side angle pair. That means we cannot use sine rule. That's not going to work. It's actually a common cosine rule case because we have two sides given and the angle between them given, right? Remember, we discussed this. This is one of the cases where you use cosine rule generally when you have two sides given and the angle between them given, and you have to find the third side. So we can use cosine rule to figure out the third side. What's the cosine rule? It looks like this: a squared equals b squared plus c squared minus 2bc cos of a. That's what we can use here. Now, the side that we have on the left side of the equation, the angle here should be the one that's opposite to that. Now we know this angle. Let me mark that here now. This angle is 146 degrees. The side that is opposite to it, AC, is what is going to be on the left side of this equation. So we have AC squared, that equals B squared plus C squared. B and C could be any of the two other sides. So I can say maybe this is B. So I have 12 squared plus 2 squared for the other side, minus 2 times 12 times 2 times cos of A. What's A? This angle here, that's 146 degrees. And that's going to give us the value for AC. You can put this whole thing in our calculator. It's from the calculator paper. 12 squared plus 2 squared minus 2 times 12 times 2 times cos of 146 degrees. And that gives me 187.79. That's AC squared. We take square root of that, and the square root of that turns out to be 13.7. That's the length of AC that we were looking for. Okay, we found that length, AC. Now it says C is the base of a cliff. C is the base of a cliff. Okay, what does that mean? This point C here, it's the base of a cliff. We have this length BC shown here again. The scale is bigger in this case. This represents 2 kilometers. Now this is a horizontal surface, right? It's the base of a cliff. The top of the cliff, D, is vertically above C. This top is vertically above C. DC is perpendicular to BC, so they've actually written down everything. This is 90 degrees. And even if they're not explicitly told us that these are perpendicular, we should understand that because this is horizontal. CD, they're saying that's vertical. So the angle has to be 90 degrees between those two sides. And we're given that DC is 105 meters. DC is 105 meters. Now notice the change in units. This is 2 kilometers. This is 105 meters. Let's convert everything to the smaller unit. So 2 kilometers is 2000 meter. So we have the same units, and that is 105 meters. We need to find the angle of elevation of D from B. Remember, when it says from something, the angle is going to be measured at that point. The angle is going to be measured at this point B. Angle of elevation. So at this point B, what's the angle of elevation? Angle of elevation is measured with the horizontal line. This angle here is the angle of elevation. Let's call this angle theta. This is what we're looking for. Okay. Now the calculation steps are going to be the same as before. It's just that you need to understand this terminology, what angle of elevation means and what angle of depression means. So the angle of elevation in this case is this angle theta. How can you find that? It's a right angle triangle. We have the perpendicular, we have the base. We just find their ratio. Tan of theta equals 105 divided by 2000. And then theta equals tan inverse of 105 divided by 2000, and that's going to give us the result. You can see what that is. Tan inverse of 105 divided by 2000. Okay, and that turns out to be 3.00. And that's the result that you have. That's the angle of elevation, 3.0 degrees. That's what we were looking for. Okay. Now, let me see if I can find a more difficult one from here. Okay, let's do this one now. The diagram shows positions of three farms A, B, and C on horizontal ground. Farm B is on a bearing of 125 degrees from farm A. AB is 950 meters, BC is 680 meters, AC is 520 meters. All of that information is given in the question itself. Show that BAC angle is 44 degrees. Okay, BAC angle. Which angle are we talking about? This angle here. We need to show that this angle is 44 degrees to one decimal place. How do you find this angle? You have three sides of a triangle given, right? It's not a right angle triangle, so we can't use trigonometric ratios directly. Can we use sine rule? We need one side angle pair at least for the sine rule. We don't have any angle in the triangle. Using this 125 as well, it's not possible to find any angle inside the triangle. So we don't have any side angle pair. So what we do instead is we use the cosine rule. Okay, let's do that. We have three sides given, right? Three sides given, and the angle is what we have to figure out. How can we do that? This is what the formula looks like. A squared equals b squared plus c squared minus 2bc cos of a. Now, if I were to rearrange this, it would look something like this. 2bc equals b squared plus c squared minus a squared. So I've taken this term to the left and a squared to the right. Why? Because it's the angle that we want to find this time, right? So I'm just making angle the subject. So it will be 2bc cos of a, that equals this. And now you can divide 2bc on the other side and you get cos of a equal to b squared plus c squared minus a squared divided by 2bc. That's what the cosine rule becomes if I make cos a the subject. Now, some people memorize this as well. If you want to do that, you can do it. Otherwise, if you know this, you can convert that to this form yourself as well. Just make cos a the subject. Now what you have to do is just input those values. Now keep in mind the angle that you have here, the angle that you want to find out, that's this angle here, right? this small side A, small alphabet A, that represents the side that is opposite to this angle. So this 680 is going to be the side A. Okay, that's important. B and C could be anything, that does not matter, but A side has to be opposite to the angle that we want to find out. So A is 680, just keep that in mind. So it becomes cos of A equal to B squared. B is any one of the other two sides, 520 and 950. So you can say 520 squared plus C squared, which is 950 squared, minus 680 squared. And then in the denominator, we have 2 times 520 times 950. We can put this whole thing on our calculator and see what that gives us. Use the fraction button. 520 squared plus 950 squared minus 680 squared divided by 2 times 520 times 950. Okay, that's what we're getting. Now we have to do cos inverse of this, right? So cos of A turns out to be this 0.7191. Now you can do cos inverse of that, and that will give you that angle that you're looking for. Cos inverse of this value, that's 44.0 degrees to 1 decimal place. And that's what we were looking for. That angle is 44.0 degrees. And that's what we were looking for. Okay, that's the first part. Now it says calculate the bearing of A from C. A from C. Okay, so you have C here after from. C is the point at which you will make north. So you have this north here at the point C. Okay. Bearing of what? Bearing of A. So what we're looking for is this angle. Okay, that's what we're looking for. How can you find this angle now? Let's think about it. We have found that this angle here is 44 degrees. 44.0, that's 44 degrees. That's what we find out. That's what we have found out. Okay. Now, how can we find this angle? Let's think about it. If this angle is 44, does that tell us anything about the remaining angle on this vertical line that we had there? What is this angle going to be? It's a straight line. Angle on a straight line is 180. So if I were to find this angle here, what would this be? This turns out to be 180 minus 125 minus 44. And that's going to give us this angle here. Let's see what that is. 180 minus 125 minus 44. And that angle is 11 degrees. Okay, so this angle here is 11 degrees. Okay, now if this angle is 11 degrees, that means that this angle here is also 11 degrees. These are alternate angles. So think of these vertical lines. We have this north and we have this north, and we have a line that's passing like this, right? This angle 11 is supposed to be equal to this angle 11, right? These are alternate angles. So that's 11. If that's 11, what's the bearing then? The total angle in a circle is 360. 360 minus 11, what does that give you? That gives you 349 degrees. And that's the angle that we were looking for. Okay, so it's the same as this 11 is the same as this 11, and then we just subtract that number from 360. Okay, let's move on. That was part B. Now part C says farm A and B are joined by a straight track AB. Okay, farm A and farm B. A and B, they're joined by a straight track AB. So you can see that, and that's 950. Amira walks along the track from A at a constant speed of 4.6 kilometers per hour. Calculate the time it takes for Amira to walk from A to the point that is close to farm C. Give your answer in minutes and seconds correct to the nearest second. Okay, so that's an important thing in trigonometry as well that you need to know. Let me add that here. We talked about angle of elevation, or maybe in the first thing. Shortest distance from a point to a line is always perpendicular distance. Shortest distance from a point to a line is always perpendicular distance. Okay, now what do I mean by that? Let's say you have a line that looks like this, and there is some point somewhere, let's say this point. What's the shortest distance from this point to this line? Now, you could calculate this distance a number of different ways, right? You could say this is the distance between the point and line, and the line, this is the distance, all of these could be the distance. If you were looking for the shortest distance will always be this perpendicular distance, such that if you were to draw a line that makes a perpendicular to that line, this is going to be the shortest distance between the point and the line. Okay, this is the shortest distance. Now keep that in mind as we look at that problem. Shortest distance between a point and a line is always perpendicular distance. Now, let's go back to that problem. Which one was that? Yeah. They're saying A and B are joined by a straight track. You can see that here. We have the straight track. Okay. Amira walks from A along the track at a constant speed of 4.6 kilometers per hour. So she starts at A and is going towards B like this. Okay. Calculate the time that it takes for Amira to walk from A to the point that is closest to farm C. Closest to farm C. Now, what is the point that is closest to farm C? This is farm C. What's the point on this orange line that is closest to the point C? We just talked about that. The shortest distance from a point to a line is always perpendicular distance. So that point that is closest to C is going to be this point here, such that we have a perpendicular angle here, but this angle is 90 degrees. Okay. Now the question is, how can we find this point? Is there a way to find this point, or in fact, not the point, but this length here from A to this point? Can we find that length somehow? We can, because we have a right angle triangle. We know the hypotenuse of this triangle, that's 520. We know this angle as well. This was 44 degrees. We found that in the first part. We can use this information to find, let's say let's call this point X. We can find the distance AX from that. Okay. Now, with respect to the angle 44, this side is adjacent. It's adjacent side. We can say that's the base. 520 is hypotenuse. What's the ratio between base and hypotenuse? It is cos. So we can say cos of, or we can say x, AX over the hypotenuse, which is 520, which is base over hypotenuse. That should equal cos of 44 degrees. And that's going to give us the length AX. Okay. That's the length AX. That's one thing that we were looking for. Once we have that, let's figure this out first of all. AX length 520 times cos of 44. This is giving me 374.06. Okay, so that's the length of AX. So the distance from A to this point is what we have found now. That's 374.06. So she is traveling a distance of, this is in meters, right? Yeah. So 374.06 meters, that's the distance that she's traveling. This is the speed in kilometers per hour. We need to find the time that it takes her to get from the point A to this point. How can we find that? You see the notice, you notice that the units are different, so we have to be a bit careful. This is kilometers per hour. One idea is that we convert this to kilometers as well. What is this going to be in kilometers? Divided by 1,000, that will be 0.37406 kilometers, right? So this distance in kilometers is this. Now, what we can do is we can find the time in hours first and see what that turns out to be. So it's going to be distance over the speed, right? Time is distance over speed. What's the distance that we have here? Distance is 0.37406 kilometers. Divide by the speed, which is 4.6. Let's see what we get from that. So this is the distance, 0.37406. Divide that by 4.6. And that gives you 0.08132. This is in hours. We want to give our answer in minutes and seconds. What do we do for that? We can multiply this by 60 first of all. What does that give us? 4.879 minutes. Okay, now what that means is we have 4 full minutes. So the number of minutes is going to be 4 here. Okay. What about the seconds now? We can break it down like this. We can say it's 4 minutes and then how many seconds? 0.879 times 60 seconds, right? So subtract 4 from this. So 4 minutes that we have counted separately. And then these minutes can be converted to seconds now, which are in decimals, times 60. That gives us 52.74 seconds. They want you to give an answer correct to the nearest second. So if you round it off to the nearest second, that will become 53 seconds. That's what you get at the end. 4 minutes and 53 seconds. That's the time that it takes a meter to walk from A to that point that we were talking about. All right. Now, let's look at the last one now. It says a helicopter hovers vertically above farm B. Vertically above the farm B. Okay, so at the point B, we have a helicopter that is hovering exactly above the point, above this point. Let's call this H, this point. Now, all of this is on a horizontal surface. All of these points are on a horizontal surface. Points A, C, B, X, all of these are on a horizontal surface. This yellow line is a vertical line. Okay, this yellow line is a vertical line. All right, that means all the angles at the point B with this vertical line, they are going to be 90 degrees. So we're going to have a 90 degrees here. We're going to have a 90 degrees with C. All of these angles are going to be 90 degrees, okay? At the point B. Any angle with the vertical line at the point B is going to be 90 degrees. Okay, now keep that in mind. The angle of elevation of the helicopter from farm A is 10.7. Okay, so which points are we talking about now? The helicopter is hovering about the point B. Okay. We can draw a right angle triangle here on the side. It often helps to draw it on the side in 2D. This is the helicopter. We have the point B. This angle is going to be 90 degrees. They are saying angle of elevation from farm A. So from the point A. So if I were to make this triangle here, AHB. Now, this triangle is going to have a 90 degrees at this point, remember. Okay, so it's often easier to draw this separately. Otherwise, 3D figures, they become a bit hard to understand from this diagram. You can draw it separately like this. You can say you have this helicopter. This is point H, and you have the point B here. and then this point A here, such that the angle of elevation from farm A is 10.7. That means this angle here is 10.7 degrees. That's what we know. Okay. What we want to find is the angle of elevation from farm C. Now, again, C is another point on the horizontal surface. If I were to make a triangle with C here as well, the angle at the point B is still going to be 90. So that is going to be another right angle triangle. And that's going to look like this. This is B, this is H, and this is C. This angle is what we are looking for. So we have two right angle triangles because they're talking about angle of elevation from two different points. One point is A and the other point is C. You can make two right angle triangles like this and think using them now. Do we know the distance AB? Distance AB is 950. Let's mark that here as well. AB distance is 950. So in this triangle, we know that this distance is 950. We also know the distance BC, that is 680. We can use that here. This distance is 680. Okay. Now, what we have to do is we have to find this angle theta somehow. Now, in the lower triangle, we don't have enough information. We only know one side. But in the upper triangle, we know an angle, we know the side. What we can do is, in the upper triangle, we can use some trigonometric ratio to find HB, right? The height of the helicopter above the point B. How can we do that? With respect to this angle, HB is opposite, which is perpendicular, and 950 is adjacent, that's the base. What's the ratio between perpendicular and base? It's tan. So we can say perpendicular, which is HB, divided by the base, which is 950, that equals tan of 10.7 degrees. And that can give us the value of HB. Let's see what that turns out to be. 950. So 950 will go to the other side, get multiplied with tan of 10.7. 950 times tan of 1.7. Sorry, 10.7. And that gives me 179.5. This distance turns out to be 179.5. Okay, HB is this. Now that we have found this distance, 179.5, what we can do now is we can use this triangle to find the value of theta. We know the perpendicular, we know the base. We can use tan theta now. We can say tan theta equals 179.5. Right? We found the distance from using this above triangle. And now we can say tan theta equals 179.5 divided by 680. We can find the value of theta from this. This divided by 179.5 divided by 680. And we can do tan inverse of this. That gives us 14.79 to one decimal place, because answers in degrees are normally written to one decimal place. We get 14.8 degrees. That's the angle of elevation that we were looking for here. That's 14.8 degrees. Make sense? So this is how we find angle of elevation, angle of depression, and this is how we work with 3D trigonometry problems. You need to remember, whenever you have a vertical length, vertical side, the angle, all the angles at the base of that vertical, they are all going to be 90 degrees. So you can make multiple right angle triangles like this to find the unknowns, like we did in this case. Okay, I hope that makes sense. That's it for today. There's one small thing left, and that's about obtuse angles. As far as the O-level syllabus is concerned, for IGCSE, we also need to do a few more things, which we will be doing in the next class, which is solving equations involving sine and cos functions, and also some exact values of sine and cos sine, cos, and tan that you need to remember. We will be discussing them in the next class then. And in the next class, hopefully we can wrap this topic up before we start angles then, inshallah. Okay, that's it for today. I'll see you again in the next class. Allah Hafiz.